So we're going to be solving rational equations today. So our goal when we're solving any type of equation is to get x equals blah, 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 some number. And there's different ways that we can solve them. We are going to look at specifically one method, but if you look up a YouTube video or something, you might see a different method of solving. Both of them work. So our goal is going to first, if we need to, factor the denominator. Obviously for this problem, there's no denominators really that can be factored. So then we're going to create something called our LCD, which stands for least common denominator. So your least common denominator, imagine if you were adding or subtracting these fractions together, what denominator would you try to make them?
Make them all the same?
Make them all the same. So number-wise, we would do 12, because if we see we've got a 2, a 4, and a 3. There's like a delay on my thing. So our least common denominator for those would be 12. For the x's, we would need an x squared, because we have an x squared that appears in our denominator. One of our denominators has it has 2 x's, so all of them would need 2 x's. Actually, I'm not going to use grades. So what we're going to do is we are going to multiply each one of our numerators by our LCD. So once we get our LCD, all of my numerators I'm going to multiply by 12x squared. And what that's going to do is allow us to reduce or to cancel out our denominators. So if we look, 2x and 12x squared, they can reduce. The 2x would cancel out, and the 12x squared would reduce to a 6x. So my first term would become a 5, that was a wonky 5, a 5 times 6x. I would then reduce my middle fraction. So the 4x squared and the 12x squared can reduce. The 4x squared would cancel out, and the 12x squared would become a 3. So now my numerator becomes minus 3 times the 3 that's left over. And my last fraction would cancel out. The 3x and the 12x squared would reduce down to a 4x. So I'd be left with a 2 times 4x. And once we cancel out those fractions, then it just looks like a normal equation that we've done before. Okay? There's no more denominators. You're just distributing, combining like terms, and solving. So 5 times 6x, we'd have 30x. Minus 9 equals 8x. Subtract 30x from each side, so all of our x's are on one side. To get negative 9 equals negative 22x. And then divide by negative 22. The negatives cancel out, so x equals 9 over 22. Now before we box this, remember with square roots we had to go back and plug in and make sure that they worked. We have to do something similar here. You don't necessarily have to go back and plug it in, but you have to make sure that when we go back, none of these denominators here would equal 0 if we plugged them in. So 3 times 9 over 22 is not 0. 9 over 22 squared times 4 is not 0. And 3 times 9 over 22 is not 0. So our answer is 9 over 22. And we will do one where it doesn't work. So you'll get to see what it looks like.
Which numbers are you plugging in?
I'm plugging in my x equals into my denominator of my original equation. So 2 times 9 over 22, that does not equal 0. As long as it doesn't equal 0, you're good.
As long as it's not exactly 0.
Exactly. So if we had gotten like x equals 0 when we plugged in, 2 times 0 is 0. So that wouldn't have worked. Yes. box.
The way you like plug the x equals into that, you do 2 times 9 divided by 22?
Correct. All right, so let's look at number 2. All right, so the first thing we need to do is check to make sure our denominators are factored. Can't factor our denominator, so check, we're good. So then we're going to come up with our LCD. And again, our LCD is what we would try and make the denominators if we were adding or subtracting. So the x minus 2 and the x minus 5 are whole terms. We can't just take the pieces. So this left side has an x minus 2, which means I need an x minus 2 in my LCD. This right side has an x minus 5, so that means I need an x minus 5 in my LCD. So my LCD is both terms that appear. So I'm going to take my LCD and write it next to each of my factors, or each of my fractions. So x minus 2, x minus 5, x minus 2, x minus 5. And then if we did this correctly, our denominators should all cancel. So as I look on my left side, my x minus 2 and my x minus 2 will cancel. So I'll just be left with an x plus 3 times an x minus 5. On my right side, the x minus, wrong color, the x minus 5s cancel. So I'd be left with an x plus 4 times an x minus 2. And then when we multiply these, we have to distribute. So I can distribute the x to each, and then I'll distribute the positive 3 to each. So I'll get x times x is x squared. X times negative 5 will be negative 5x. 3 times x will be 3x, and 3 times negative 5 will be negative 15. We need to do the same thing with the right side of our equation, so we'll distribute the x to each term and distribute the positive 4 to each term. So x times x will give me x squared. X times negative 2 will give me negative 2x plus 4x minus 8. So then we'll combine like terms. So our left side will be x squared minus 2x minus 15 equals x squared plus 2x minus 8. All right, so let's try and make it equal 0. So I'm going to subtract an x squared from each side, which will cancel out my x squareds. Sorry. So I'll get a negative 2x minus 15 equals 2x minus 8. We're going to try and get all of our x's on one side, so you can get them on the left or the right. I particularly like my x's always on the left, so I'm going to subtract 2x from each side. So negative 4x minus 15 equals negative 8. Add 15 to both sides. So negative 4x equals 7. And then divide by negative 4. So x equals negative 7 over 4. Now we need to make sure it doesn't make our denominators equal 0 before we box it. So if I look at my original denominators, negative 7 over 4 minus 2 does not equal 0, and negative 7 over 4 minus 5 does not equal 0. So this answer works, so we can box it. something that would not have worked. So say we got x equals 2 as an answer, or x equals 5 as an answer. Those would be extraneous. We'd cross them off, not use them. All right, number 3. 3 over x minus 1 minus 2 over x minus 4 equals negative 6 over x squared minus 5x plus 4. So first thing we want to do is always to factor our denominators. So my first denominator and my middle denominator don't need to factor, but this last term can factor my denominator using factor sum. So I'm looking for two numbers that multiply to 4 that add to a negative 5. Nick?
It should be x minus 1, x minus 4.
An x minus 1 and an x minus 4. So I can replace it, and instead of rewriting the whole problem, I'm just going to write it that, and then maybe like cross this off, so that I don't have to rewrite it. So now that we factored the denominator, we can find the LCD. So our LCD is whatever appears in our denominator. So we have an x minus 1 that'll appear, and an x minus 4 that appears. Now, it only appears in each denominator once, so we don't have to write it twice. You can ask my LCD next to each one of my fractions.
That's what I'm gonna read it as.
You're going to read it as LSD. Hello to all those people watching this at home. X minus 1, x minus 4. So then we'll start canceling things out. So for my first fraction, the x minus 1s can cancel. So I'll be left with a 3 times x minus 4. From my middle fraction, the x minus 4's cancel. So I'll be left with a minus 2 times x minus 1. And from my last fraction, x minus 1 and x minus 4's cancel out. So I'd just be left with a negative 6. And now it's just a normal equation where we can solve. So we'll distribute the 3 to get 3x minus 12. And distribute the negative 2 to get negative 2x plus 2 equals negative 6. So make sure you distribute the negative on there, not just the 2. So we combine like terms will give us x minus 10 equals negative 6. Add 10 to each side to get x equals 4. Now before we box, we want to make sure it doesn't make our denominators equal 0. So 4 minus 1 does not equal 0, but 4 minus 4 does equal 0. So because one of my denominators equals 0, that means this x equals negative 4 is what we call an extraneous solution. And specifically for this problem, it's because it would make our denominator equal 0. So for this problem, we would have no solution because that 4 did not work. If we had 2 solutions, then our answer would be just the other solution. You guys are going to try number 4 on your own. So 5 over x plus 3 equals 2 over x squared minus 9. Nope, that should not be an equal sign there. There should be a plus sign. Then equals 4 over x minus 3. And remember, you always want to factor your denominator first before getting your LCD. So if you're at home, pause the video and try this one yourself. All right, check your answer. You should get x equals 25.
Yes.
Again, the key is to factor this denominator first into an x plus 3, x minus 3. That is the key part, so we can cross that off. Always factor your denominators first if possible.
I'll think about it.
Don't think about it, be about it.
What you say be about it? Let's keep her just one thing at hand. It's about it.
All right, number 5, 2 over x equals x over 5x plus 12. All right, so our first thing would always be to try to factor denominators. Neither of these denominators factor. So then we can go on to our LCD. LSD. Whatever appears in your denominator becomes your LCD. So we have a plain x that appears and a 5x plus 12 that appears. So what I'm going to do is next to each one of my numerators write x, 5x plus 12.
We just write 5x squared plus
Yeah, I was gonna say.
You can, but you want to keep it factored so that everything cancels.
I understand.
All right. Our x's here will cancel on our first fraction. So we'll be left with 2, 5x plus 12. And the right side, the 5x plus 12s will cancel. So we'll be left with x times x. Distribute. So we get 10x plus 24 equals x squared. And anytime you have an x squared in your problem that you're trying to solve, you want to make it equal 0 so you can factor. So yes, we could subtract this x squared over so that the right side equals 0, but then you'd be left with a negative x squared. And you don't want a negative x squared because our factoring rules don't work with that. So I'm going to subtract 10x from each side and subtract 24 from each side, so that the left side will equal 0 and the right side will still have a positive x squared. So 0 equals x squared minus 10x minus 24. And now we need to either factor or use the quadratic formula to solve this. So we're going to factor. We're looking for factors of negative 24 that have a sum of negative 10. So two numbers that will multiply to a negative 24 and add to a negative 10. Negative 12 and positive 2. No, negative 6 and negative 4 would not work. So we get x minus 12 times x plus 2. Since it equals 0, we would get x equals 12 and x equals negative 2. Confirm that they would not make our original denominators equal 0. They would not. So for this problem, we would have 2 solutions. So the first thing we always want to do is factor our denominators. So our bottom left one, factor sum, two numbers that multiply to negative 2 that add to 1, would be a positive 2 and a negative 1. Good job, guys.
No, that's wrong.
Our middle one, two numbers that multiply to 2 that add to 3, would be a positive 2 and a positive 1. And our last one would be a difference of squares. It would factor into an x plus 1 and an x minus 1. So then we need to find our least common denominator. So it's anything that appears in our denominator. So we have an x plus 2, an x minus 1, and an x plus 1 are the terms that appear in my denominator. So I'm going to write this next to each one of my numerators. Write small. So then we start canceling. On our first fraction, the x plus 2's and the x minus 1's would cancel. So I'd be left with an x times x plus 1. On my middle one, the x plus 2 and the x plus 1 would cancel. So I'd be left with an x minus 1. And on the last one, the x plus 1 and the x minus 1 will cancel. So I'll be left with an x times x plus 2. You'll then want to distribute. So distribute the x, I get x squared plus x equals, distribute the x squared minus x. And on the last one, make sure you distribute a negative x. So I'll get a negative x squared minus 2x. So that wouldn't be combined like terms. The x squareds cancel out. So x squared plus x equals negative 3x. Anytime there's an x squared, you want to make it equal 0. So I'm going to add 3x to each side. So that x squared plus 4x equals 0. And then my method of factoring I'm going to use for this would be a GCF. So I'd factor out an x. So I would get x equals 0 and x equals negative 4. You'd want to confirm that none of your denominators would equal 0. So my LCD is my denominators. None of those would equal 0 for 0 or negative 4. So this one again has two answers.